Hello. Uh, Quite a cool question, this one here. Um, it tells us the first thing about a bulb and a cell with no internal resistance. So we're not looking at the left-hand diagram to begin with. We've just got a bulb and a cell, no internal resistance. And they tell us voltage and power. Now, when I'm thinking about what I'm going to do in that second circuit, the thing I probably will need is the resistance of the bulb, because that's the only thing that won't change. So let's work that out. The equation is V squared over R for power. Rearranging that, we get resistance is V squared, 20 squared divided by 153.85. Which is 2.6 ohms. So going to my diagram now, I'm just going to annotate what I can, 20 volts and a 2.6 ohm, that should be a bulb, and it's producing 95.5 watts. Now, at this stage, I could use the current, so I could use P equals I squared R, I could use V squared over R. It doesn't matter, I'm just going to go with voltage. So what do I get? P is V squared over R, and therefore the voltage, which I'm trying to get, is the square root of PR. The square root of 2.6 times 95.5, which is 115.76 volts. And if I find out the difference between that and the battery, that tells me the voltage across the internal resistance, which is 4.24. And now it's back to the old ratio problem, and therefore I can use ratios to work out the resistance of the cell. It's going to be the ratio of the voltages, 4.24 divided by 15.76 times by the resistance of the bulb. So 4.24 divided by 15.76 times 2.6, and that gives me 0.7 ohms